Okay, so this is question number 10. Let me write this down on the diagram below. You have RQ is 9 cm, RS is not cm, it's m. So this is 12 m, ST is 13 m, angle Q this is 60, angle SQT is 40. First question, find the length of QS. So let me draw the diagram. Figure is not to scale. This is an approximate diagram. So R, Q, 12M, 9M, S, T, and ST is 13. SQT 40 degrees. QRS is 60 degrees. Now we are asked to find the QS. Now we will use cosine rule. So from cosine rule, QS, right, is QS squared is equal to RS squared positive RQ squared negative 2 times of RS taken as a product with RQ times cosine of the angle between them, 60 degrees. So RS squared is 12 squared, RQ is 9 squared. So 12 times 9 times cos 60 is 1 over 2. 2 gets cancelled. So 144 positive 81, 9 2s are 18, 108. So 144 with 81, 5, 12, 1, 2. From this you take away 108, 7, 1, 117 you get. So QS squared is equal to 117, therefore QS is equal to root of 117. So find the value, square root of 117, 10.8. QS is 10.8 m. Okay, so that's a solution for the first part. Now second part is find QTS. So find this angle. They want us, this is question 2, find angle QTS. Okay, QTS, what is this angle? Now I'm going to use sine rule. So this is 10.8, right? So this side over by sine rule, 10.8 over sine of angle T is equal to 13 over sine of 40. Okay, this over this, this over this. So 10.8 multiplied with sine 40 divided by 13 is equal to sine T. So 10.8 divided by 13. What is that? 0.83. I'm taking it as 1. 0.7 is there, so I'm taking it as 1. Multiplied with sine 40. So sine of 40. This is 0.6428 multiplied with 0.831. So 0.6428 multiplied with 0.831. So therefore sin t is 0.5342. T is equal to sin inverse of 0.5342. So use the shift key, sin inverse of 0.5342. So T is equal to 32.289. So I take it as 29 degrees. Okay, 32.29 degrees is what we have got. Right. So if you're going to round it up to one digit, after a decimal place you need only one digit. You can take T is equal to 32.3 degrees. Okay. Now area of triangle QR. Yes, this is third one. Third one, area of QRS. We need area of QRS. That means I'm going to use this formula. Area is equal to half times AB sine theta. So half times 12 into 9 into sine of 60. So 2 divides 6 times 6 9 is 54. Sine 60 is root 3 over 2. 2 divides 27 times. 27 times root 3. So if I take root 3 as 1.7321, so let me check that out. So 1.732 multiplied with 27. So this is 46.77. 46.77 square meters area. Okay, I hope you're watching it. Okay, 77, or you can take it as 46.8 square meters, right? Since we are only taking one digit after the decimal. Okay, so the next point is they are asking us to find the perpendicular distance. You see here, they want us to find this perpendicular distance. So that means this is 90 degrees. So we can utilize this formula. So I'm going to utilize this area is equal to half into base times height. The area is given as 46.8. Area of this center triangle is 46.8. Half into the base is 12. Height is needed. Okay, so 2 divides here 6 times. So 6h is 46.8. So h is equal to 46.8 divided by 6. So what do you get? 7.8. 7.8 meters. So this is a lovely question, and we have successfully completed all the parts. For this part of the question we need a figure. So let me draw a circle. Okay, so we have the circle there, and you have to draw the tangents. So let me draw the tangents. So there is the center and you have point H. So there are two tangents hitting parallel. Okay, so this point is H, and you have a hit here. The radius hitting the tangent. You have a hit there. So this is J, and there is also a hit here. And this is L, this is O, this is G. And there is a hit also here. Figure is not to scale, so you have to visualize it. Now they are asking us to find angle OJH. OJH. So this is 48 degrees. Now OJ is a radius and JH is tangent to circle O. By tangent theorem, okay, I hope you got the figure. So this is the figure, and we are asked to find OJH. So the line is stretching like this, and the radius OJ is meeting the tangent at J. So by tangent theorem, the radius OJ makes an angle of 90 degree with the tangent. Okay, so this is 90 degrees. Also OG, which is a radii or radius of circle, will also make an angle of 90 degrees with GH. So this will also be 90. So the question is OJH is equal to 90 degrees. That's the answer to the first question. Now the next question is they're asking what is the angle of JOG. So they want this angle. Okay, they want JOG. Now clearly OJHG is a quadrilateral. Okay, it's a quadrilateral, and the angle at angle J is 90, angle G is 90, angle H is 48. Therefore angle O is angle J plus angle G plus angle H. You add up all these things and take it out from 360 degrees. Take this sum from 360, so 360 degree minus of 90 plus 90 plus 48, so 180 plus 48, 82228. So from 360 you take 228, 10, 2, 5, 3, 132. So angle at O is 132 degrees. So this angle is 132 degrees, and question number 2, JOG is 132 degrees. Now this point is K. Now the next question wants us to find JKG. Okay, so we are going to use this theorem. Okay, the circumference equals half the angle at the center. So what is the angle at the center? 132. So you divide by 2, 6 and 6, 66 degrees. So question number 3, JKG, right? JKG is equal to 66 degrees. Okay, now next question number 4, they want us to find the angle of JKG. So this is JKG, this is JLG. Okay, they want us to find the angle of JLG, this angle. Now clearly JKGL is a cyclic quadrilateral. Okay, cyclic quadrilateral. So that means the opposite angles add up to 180 degrees. So I'm going to put this here. So angle at L plus 66 is equal to 180. Therefore angle at L is equal to 180 minus 66. So from 180 you take away 66, you get 4. From 7 you take away 6, you get 1. And this is going to be 114 degrees. So JLG is equal to 114 degrees. Okay, so that's the solution for this question.